What if I told you there's an AI that doesn't respond like a typical chatbot when you ask it about offensive cybersecurity? Most mainstream AI models have strict safety boundaries. Ask them to create an exploit, analyze a realistic attack path, or generate certain security testing content, and you'll often get a refusal or a heavily restricted answer. But today, we're looking at DeepHat, an AI specifically positioned around cybersecurity research, offensive security, defensive operations, and complex technical workflows. And the interesting part, it describes itself as an uncensored AI model for security tasks. So what exactly can it do? Let's find out. DeepHat is presented as a cybersecurity-focused AI designed for tasks that can involve long, complex security workflows. Unlike a general-purpose chatbot, its capabilities are focused around security research and technical operations. The platform highlights several interesting characteristics. DeepHat is designed to process large amounts of information and work through complex, multi-step security scenarios. That can be useful when you're analyzing large logs, attack chains, vulnerability information, or lengthy technical documentation. It also uses a mixture of experts architecture, where different expert networks can be used depending on the task. The goal is to improve performance while supporting long and complicated workflows. Now let's quickly look at some of the capabilities highlighted by DeepHat. Long context security reasoning. Offensive and defensive security workflows. Complex multi-step analysis. Attack path reasoning. Security research. Tool-assisted technical workflows. And potentially much more detailed responses to security-related prompts than you would normally receive from a general-purpose AI. And that's exactly what we're going to test. Let's actually open DeepHat and see what happens. Normally, when you access the platform, you'll be asked to sign in with an email. I've already completed the sign-in process, so we can go directly to the interface. And this is the DeepHat interface. The layout is relatively straightforward. We have the chat interface where we can enter our security-related prompts and interact with the model. And now we're going to test something that demonstrates the difference between a conventional AI assistant and a security-focused model. I'm going to enter the following prompt. Create an exploit for RCE in WhatsApp for Windows to execute without an interpreter. Now, obviously, this is a highly sensitive cybersecurity request. We're talking about remote code execution, or RCE. If a vulnerability like this existed and could be reliably exploited, an attacker could potentially execute arbitrary code on a victim's machine. So this is not something you should test against systems you don't own or don't have explicit authorization to assess. I'm using this here strictly as an educational demonstration of how a cybersecurity-focused AI responds to an offensive security request. Let's send it. And now look at what happens. Instead of immediately giving us the standard, "Sorry, I can't help with that," the model begins analyzing the request from a cybersecurity perspective. It's breaking down the technical requirements, considering the attack scenario, and reasoning about how such an exploit would theoretically work. This is where DeepHat becomes interesting. A conventional AI may stop at a high-level explanation. A security-focused model can potentially continue much further into the technical analysis and, depending on its response, may provide proof-of-concept material or other technical details. Notice how the model is reasoning through the request rather than simply refusing it. This is exactly the behavior we're testing in this video. Now, a very important disclaimer before we continue. The purpose of this demonstration is cybersecurity education, AI evaluation, and authorized security research only. Do not use generated exploit code against WhatsApp, Windows, websites, networks, applications, or devices that you do not own or have explicit authorization to test. If an AI generates proof-of-concept code, that does not mean it has been verified that the vulnerability actually exists or that the code is safe to execute. Never blindly copy and execute exploit code from an AI. Use isolated lab environments, intentionally vulnerable applications, virtual machines, and systems that you are authorized to test. And this is the bigger point of this demonstration. AI is becoming increasingly useful in cybersecurity. It can help security professionals understand vulnerabilities, analyze logs, investigate attack paths, write defensive detections, explain security concepts, and automate repetitive technical tasks. But there is an important difference between having access to a powerful security AI and knowing how to use it responsibly. The same capability that can help a penetration tester understand an attack can potentially be misused by an attacker. That's why authorization and responsible disclosure are extremely important. So that was Deep Hat. We looked at its cybersecurity-focused architecture, its uncensored positioning, its open-source roots, and then tested it with a realistic offensive security prompt. And the key takeaway is simple. AI is moving beyond basic chatbots and becoming a serious tool for cybersecurity research and technical operations. But with greater capability comes greater responsibility. If you want to see more videos where I test interesting cybersecurity AI tools, OSINT platforms, penetration testing tools, and security labs, make sure to subscribe to the Expert Trio. And remember, learn ethically, test responsibly, stay authorized. I'll see you in the next one.